Hello and welcome back to Math 8. This is a video over Section 5, and what we're going to be doing in this section is we're going to be using addition to solve systems, okay? Our objectives today, we want to use linear combination method to solve linear systems. So what does that mean? Linear combination. I call this elimination, okay? And the point is, the point of elimination is we want to eliminate, okay, one of the variables. All right. And we do this, okay, so this is done by using what we call opposite coefficients. Opposite coefficients. Okay. Now you're probably wondering, what is a coefficient? A coefficient is the number in front of the variable. Okay. And that's what we've got. All right. So what we do, let's just, read through this list. This list does tell you how to do this. So we want to determine which variable will be eliminated by confirming that there are opposite terms. Add the equations together to create a one-variable linear equation. Solve to determine the unknown variable in that equation, and then substitute that variable that you just found into the original equation and solve for the other variable. Verify the solutions system of equations. So here's what we've got. Okay, now we just want to solve this system of linear equations using the linear combination method. Okay, so now here's what I've got. Okay, what you want to do is you want to look at the numbers that are out in front of your variables. Okay, here I've got a -1, a 1. Here I've got a 1 and a 2. Okay, now I'm looking for opposite coefficients. Okay, now what I notice here is that my x here is a -1 and this is a +1. Okay, so these are opposite. So we are going to eliminate the x, okay? Eliminate x because -1 and 1 are opposites. Okay, so here's what I got. Okay, I've got -x plus y equals 2, x plus 2y equals 7. So what I'm going to do when I have this type of situation, now notice that both of these equations are in standard form. Okay, they're not in slope-intercept form. So I'm looking at that. When they're both in standard form like this, I want to use elimination, okay, especially if I have opposite coefficients, all right? So what I'm going to do when I notice that, I'm just going to add them together. Okay, and add them up. So I've got -x and x. Now, when I add these two terms together, they're going to add to 0. Hence, they cancel out. So I'm just going to cross them out. All right. Then what I have is I have y plus 2y. Well, that's going to give me 3y, and that's going to equal 2 plus 7, which is 9. Now, what I want you guys to notice here is that, I have eliminated the x. So now I have an equation that I would just be able to solve for y. So I'm going to divide both sides of this equation by 3 and 3. So I get that y is equal to 3. All right? That's my value for y. Okay? So now what I'm going to do is I'm going to plug this back into one of the original equations, just like we did in the previous video. Okay? And it, depends on which one you want to use. It doesn't really matter trying to determine which one's easier or not. They're both pretty similar. So what I'm going to do, I'm just going to plug it into the first equation. Okay, so I'm going to get -x plus y. All right, so I'm going to plug it in up here. -x plus y, but y is equal to 3. So I'm going to plug in 3 for y. So I've got -x plus 3 is equal to 2. Now what I'm going to do is I'm going to subtract 3 from both sides. Okay. And so then I get -x is equal to -1. Okay, now because I have a -x, I want to get rid of that negative. So I'm going to divide both sides by -1. Okay, negatives are going to divide out. And so then x is just going to equal 1. All right, so I've got x equals 1, y equals 3. So my solution, okay, is going to be 1, 3. All right. So now we can check this algebraically, or we can check this graphically. Let's check this algebraically real quick. So let's plug this into negative x plus y equals 2. So let's check. All right. Let's plug in negative x. So negative x is negative 1 plus 3 equals 2. All right. So I've got negative 1 plus 3. That's going to give me 2 equals 2. That's true. So we're good. All right. Let's plug it into the next one. I'm going to do 1 plus 2 times y, which is 3. Is that equal to 7? So I've got 1 plus 6 equals 7. So I got 7 equals 7. That is true, and we're good on that. So this is our solution. All right. Okay, let's talk about a systems with no solution. Okay. Now, I will graph these to show you, but let's do linear combination here. And let me rewrite this out over here as 2x plus y equals 5, and then negative 2x minus y equals 2. Okay. Now, what I'm going to do for both of these, noticing that I have an opposite coefficients for my x and opposite coefficients for my y value. Okay. So I noticed that, but I'm going to combine them. All right. And then what's going to happen is I'm going to get 2x minus 2x. That's going to cancel out and give me 0. Same thing over here. Y minus y is also going to give me 0. So I just get 0 on the left side of this equal sign. And then 5 plus 2 is going to give me 7. So now I have 0 equals 7, and this is a false statement. Okay? So therefore, if I have a false statement, that means I have no solution. Okay? And what we have is we have, parallel lines. Okay? So let me do this. All right? Let me take 2x plus y equals 5. All right? And let me solve this equation for y. All right? So I'm going to move my 2x over. So negative 2x. All right? And I've got y equals negative 2x plus 5. All right, so that's one equation. The other equation is negative 2x minus y equals 2. So I'm going to add 2x to both sides. So I get negative y is equal to positive 2x plus 2. Now I'm going to divide everything by negative 1. Okay, and that's going to give me y equals negative 2x minus 2. Okay, so now notice here, all right, in this equation, I have a slope of negative 2. I have a y-intercept of 5. Here I've got a slope of negative 2 and a y-intercept of negative 2, all right? So I've got both. So notice here is that I have the same slope. All right, so slope is equal to negative 2. So same slope. Let's graph these real quick. So a y-intercept of 5, slope of negative 2. So down 2 over 1, down 2 over 1, and so forth. Okay, to graph this. All right, so I have a line here. Okay, the other one I have a y-intercept of negative 2. So we go down 2 over 1, down 2 over 1. All right, and we follow this same path as the other one, okay? And so what you have is you have parallel lines, all right, that don't intersect, okay? So, what I'm doing is showing you guys graphically why we have no solution, okay? Simply just solving it like this and getting a false statement is enough, okay? But I'm going the extra mile to show you, to graph it to show you that they don't intersect, okay? Let's take a look at the next page. Okay, so on this next one, I want to show you a system with infinite solutions. So I want to examine this system of equations, with x and y variables in constant opposite terms. So notice here that negative 4x, the x terms are opposite coefficients. The y terms have opposite coefficients, and then my constant terms are opposites. Okay, so if I come in here and simply just add them together, okay, I'm going to get 4x minus 4x, all right? That's going to cancel out to 0, all right? Then I've got negative 3y plus 3y, okay? That's also going to cancel out to 0, all right? So plus 0 is equal to positive 2 minus 2 gives me also 0. So what I end up getting is I get 0 is equal to 0, which is a true statement. And if I have a true statement, that means I have infinite solutions. Okay, and that's that. All right, so let's take a look at the graphs of these. All right, so I'm going to do this. I'm going to do 4x minus 3y is equal to 2. And then the other one I had negative 4x plus 3y equals negative 2. Okay, so I'm going to subtract 4x from both sides. Okay, and that's going to give me negative 3y is equal to negative 4x plus 2. And then I'm going to divide this by negative 3 on everything. Okay, so I've got y equals positive 4/3 x minus 2/3. All right, so that's one equation. Now, if I go over and solve this equation over here for y, okay, we'll get the same thing. So add 4x to both sides. All right, so I get 3y is equal to 4x minus 2. Divide by 3, divide by 3, divide by 3. I get y is equal to 4/3 x minus 2/3. Okay, so now notice that I have the exact same equation. All right, the other equation on the last one, you had the same slope, but you had different y-intercepts. This is the exact same. So I have a slope of negative, or a y-intercept of negative 2/3. Write it down here. Okay, and then I'm going to go, what is it, 4/3? I'm going to go up 4. So 1, 2, 3, 4 over 3. 1, 2, 3. Okay, down 1, 2, 3, 4 over 1, 2, 3. Okay, and so these lines, okay, are on top of each other. All right, and that's the thing. Okay, I only have one solution. All right, so they're the same. All right, so that's all I got for this video. Hopefully you enjoyed it. Hopefully you see the light on this, and we'll talk to you soon. Thanks a lot. Bye.